Welcome to all in the new lecture. So here we will discuss about the operations of graphs. So we have here some operations that we use in our the graphs. Means we can calculate our graphs by these operations. So now first of all is union. All of you know about the union. What is the union? How can we calculate if we have the two sets? Then how can we calculate our union? So same here we have the vertices in the graph. So here suppose we have the two graphs G1 and G2, then their union will be a graph such that actually when we talk about the graph, so what two things we need? Vertices and the edges. So always when we talk about the graph, so we need the vertices and the edges. So first of all, vertices, if we have the two graphs G1 and G2 here, so what will be the vertices in our the union of these two graphs? So the vertices of the G1 union G2, that will be is equal to the vertices of G1 union vertices of G2, and edges of the graph G1 union G2, that is equal to the edges of G1 union edges of G2. So how can you see this? Here we can take, suppose our graph G1 is this. How here we have the vertices are A, B, C, D. Four vertices are there and four edges are there. E1, E2, E3 and E4. And another one means G2 graph we have, in which we have the three vertices are there B, D, E, and three edges are there E4, E5, E6. So now what will be the union of these two graphs? It means G1 union G2. So first of all we need the vertices. So how many vertices in our G1 union G2? The union of all these vertices. So we have the total vertices are A, B, C, D and E, right? And the edges. So total edges we have to take here all edges which are included in G1 and in G2. So we have to take all these edges. So this is our E1, E2, E3, E4, E5 and E6. So this is our the graph of G1 union G2. Clear it? Now next one is intersection. So you know already that if we have the two sets, so how can we find the intersection? So same thing is here. If we have suppose two graphs are there G1 and G2 with at least one vertex is common, then their intersection will be a graph such that vertices of G1 intersection G2, that is equal to the vertices of G1 intersection vertices of G2. It means that we have to take that vertex in our G1 intersection G2 which is common in both the graphs G1 and G2. And if we talk about the edges, so edges of G1 intersection G2, that is equal to the edges of G1 intersection of edges of G2. It means that we have to take that edges in our graph of G1 intersection G2 which is common in both the graphs. So now here if we have suppose G1 graph is that, here we have the vertices are A, B, C, D and edges are E1, E2, E3 and E4. And our second graph of G2 is B, D, E vertices and edges are E4, E5 and E6. So can you tell me what will be the graph of G1 intersection G2? So how many vertices in our G1 intersection G2 graph? So which vertices are common in both these graphs? B and D. So our vertices in our graph G1 intersection G2, it is two vertices are there B and D. And what edge is common in both the graphs? Only E4. So this is our E4. So this graph is 4 are the graph of G1 intersection G2. Clear it? I hope you have to clear it. Now, next one is sum of two graphs. Sum of two graphs means if we have the two graphs G1 and G2, then how can we calculate G1 plus G2? So, when you draw the graph of G1 plus G2, so you have to remember that the vertices of G1 intersection vertices of G2, it must be equal to 5. It means that uh, to find the G1 plus G2, we have no vertex should be common in both the graphs. And vertices, we have to take the vertices of all graph, all vertices of G1 and all vertices of G2. We have to take the vertices both the graphs, but no vertex should be common in these graphs. And the edges is the set consisting those edges which are in G1 and in G2. Means we have to take all the edges which are in G1 and G2, and after that we have to take also the edges which is obtained by joining each vertex of G1 to each vertex of G2. You can clear it after this example. Suppose we have this is our the graph G1. Here we have the two vertices are there AB and one edge is this AB. Now another graph, suppose G2 we have, in which we have the three vertices are there C, D, E and two edges are there, and we can see that no vertex is common in both these graphs. Here our vertices are AB and here our vertices are C, D, E. So now our vertices intersection of these vertices is 5. After that, when we find the graph of G1 plus G2, so how many vertices in this? In this we have all the vertices of G1 and G2, that is A, B, C, D, E. And if we talk about the edges, so we have to take all the edges which are in G1 and G2. So first of all, we have to take all the edges which is in G1 and G2. After that, I according to the definition, we have to join each vertex of G1 to each vertex of G2. We have to take that edges. So now, if here the edge A, this is connected to each vertex of G2. So these edges are also included in our G1 plus G2, and from B all edges which are connected to all the vertices C, D, E. So this complete graph is called the graph of G1 plus G2. Clear it? What is the graph of G1 plus G2? Here we have to take all the vertices which are in G1 and G2 and all the edges which are in G1 and G2, and also we have to take that all the vertices are connected to each other. So that is the graph of G1 plus G2. Now the next one is ring sum. Ring sum, if we have suppose two graphs G1 and G2, then the ring sum of G1 and G2 we denote it by this symbol, G1 direct sum of G2. This is the ring sum here. And so now our graph G is defined is that the vertex of G, means here G, we see that G1 ring sum of G2, we simply says that this is graph of G. Okay. So now the vertex of our this ring sum G, this is equal to the vertices of G1 union vertices of G2. Means we have to take all the vertices of the G1 and G2 here. And if we talk about the edges, so edges of the our required graph, this is equal to the edges of G1 union edges of G2 minus in edges of G1 intersection edges of G2. It means that we have to exclude that edges in our required graph which is common in both the graphs. So that is the edges that either in G1 or G2 but not in both, we have to take that edges. Okay. So now suppose this is the G1 graph in which we have the four vertices are there A, B, C, D, and edges are E1, E2, E3, E4, E5. 5 edges are there. And G2 graph we have in which we have the four vertices are there A, B, D, E, and four edges are there E1, E5, E6, E7. So now what will be the graph of G1 ring sum of G2? So in which we have to include all the vertices which in both in the graphs. So our vertices are A, B, C, D, E. So all vertices which are common in both G1 and G2, we have to take this. Now come to the point of edges. So in edges we have to exclude which is common in both the graphs. So which edges are common here? E1 and E4, E5, E1 and E5. Two edges E1 and E5 are common in both the graphs. So we have to exclude these edges only and include all other edges. So means AC, that is our E2 edge. Now C to D, that is our E3 edge. Now D to B, that is our E4, and B to D, that is our E6, and D to E, that is our E7. So we include all the edges except which those edges which are common in both the graphs. So this graph is are the ring sum of the graph of G1 and G2. Clear it how to find it? Okay. So now next one and the last one is complement. So if you have suppose any graph G, so what will be the graph of the complement of the graph G? So the complement we denote it by G dash, and this is a simple graph with the same vertex set as G. Means vertex are all those vertices which are in our graph G that will be in our graph of G dash. And where two vertices A and B are adjacent only when they are not adjacent in G. So what does it mean? It means that we have to take the edges which are not connected in G. So we have to take those, we have to connect those edges of the vertices in our G dash. So you already know what is the complement. So here suppose this is our the graph G. Here you can see that we have the six vertices are here A, B, C, D, E, F, and these are the edges are here AC, CE, EA, BF, FD and DB, right? So now what will be the graph of complement of G? How many vertices should be there? Here you have all the vertices which are in G. So we have all the vertices which are in G, A, B, C, D, E, F. Now the edges. Which edges we have to include? We have to take not vertices which are not adjacent, which are adjacent here, right? So here A, B, we have not connected A, B here. So in our complement, we connected all these edges which are not connected in G. So like that, we have this A, B, C, D, E, F, A. So this is the edges are here, and also we can see that A is not connected to D in our G. So it will be there A, D is in our G dash, and F, C is and F are not connected. So here our B and E is connected because E is not connected here. C, F are connected because C, F and F are not connected here. So this will be the graph of the complement of G. Clear it? So these was the operations for the graphs. So now today's lecture is completed now. Thank you. Be happy. Be